First question, again, we're using this review sheet. Okay, so I'm reading the problem straight from there. Okay, just doing it on this page. But if we're given the odds are 10 to 19 in favor of winning, what is the probability of winning? Now, pay attention to the wording, okay, because sometimes they like to fool you. They'll say the odds are 10 to 19 of winning. What's the probability of losing? So you have to have a good grasp of what everything means. Odds, I like to call it wins to losses. So there are 10 ways to win and 19 ways to lose. Okay, so if there are 10 ways to win, 19 ways to lose, there are 29 outcomes. Does that make sense? Well, probability then is of winning is how many ways you can win over how many outcomes there are, 10 to 29. Okay? We got to make sure we understand the three numbers, how they relate to each other. We also have to understand winning and losing is not the best description from yesterday. Right here. Okay, but winning and losing is not the best description. Winning is kind of getting what you want. Okay. 2. Randomly select one card from 52. Probability of selecting a king or a 2. So, probability of a king or a 2. This one should be an easy one. Okay, we learned that or mean add. So, how many kings are there? 4 out of 52. How many 2s are there? 4 out of 52. The only thing we should be a little bit in question of, and this is obvious, are there any kings that are also 2s? No. If there were, then we would have to kind of subtract out the duplicates. So my probability of this is 8 over 52. We should always reduce. And with a calculator, if you just put it in as a fraction, it reduces. For any calculator that does fractions, put it in as a fraction, it reduces it nicely. Now, there is a question. We had a big debate and almost came to blows. I was ready to throw a pie at someone. Is an ace a number card?
No.
I say no. I say no because it has a letter on it. And I was shocked and amazed and surprised at how many people, I have some friends who like to play poker and whatever, how many of my friends and people said yes. Now, to me, if you ask someone, hey, what's your favorite number? They don't say ace. Okay? If you ask someone, what's that person's number on their jersey? They don't say ace. You don't see A on a jersey. Okay? But there is the ace of the bullpen. That's your number one reliever, right? And the ace comes from, I believe, a Latin term meaning one. Okay? So there is, and I'm told in many European decks, they don't have an ace, they have a 1 card. So the other thing is, if you looked at cards, you know, the 2 card has, like the 2 of hearts had 2 hearts on it, and the 3 of hearts have 3 hearts on it. Well, the ace of hearts has 1 heart on it. So ace can be certainly representative of the first card of a 1. But I still go by the idea that no one's favorite number is ace. It's 1 or something. So I still go by the idea that since ace is a letter, then it is not a number card. So we have to be clear with what our intentions are, because there are some other people who believe that it is a number card. I'll give you that it represents a number card, but because it has a letter on it, it is not a number card. It may have originated as a number card, but because it has a letter on it, it has morphed into a non-number card. All right, enough of that. Architect, now right here, this one here, we read this. Architect considering bidding, shopping mall, cost of drawing the plans is $8,000. Probability of being awarded the bid is 0.07. Architect, the anticipated profits $200,000, resulting in possible gain of this amount minus the $8,000. So they're kind of helping us out here. Okay. Cost, the $8,000 of the cost for the plans and the model. Give the expected. Now here's the thing, expected value. We got to recognize that right there when we see expected value, and we got to think chart. We got to think, what are my outcomes and what are my probabilities, and I want to multiply them together. So we got to think chart. Now, what are the possible outcomes of this thing happening? Well, they can, if he wins, it's actually, if he wins the bid, he gets $192,000. Where did that come from? Yeah, remember we said that he makes a profit of $200,000 minus the $8,000, which was the cost of the plans. Okay, so the $200,000, it says so right in here. Okay, profits are $200,000, resulting in a possible gain of this amount minus the $8,000. So we take $200,000 minus. So that means that's how much he's going to profit. And the probability was 0.7. And put an equals here. I need that. But what's the other outcome? The other outcome, he isn't awarded the bid, and so there's another there. I should know that with my number. Okay. If he doesn't get the bid, he loses the $8,000 that he paid to make up the plans. What's the probability he doesn't get the bid? 0.93. Why? Because 0.07 plus 0.93 add up to 1. Remember, 100%. This is 7%, that's 93%. Put an equal sign. Okay? So we're going to multiply this out. 192 times 0.07 is, I'm going to go green here, 13,440. And then we're going to go 8,000 times 0.93, and we're going to get negative 7,440. We need to add those two things together, and that's our answer. When you add those together, you get 6,000. This is my expected value. What does it mean? It means if the guy puts in bids like this a lot, that over the long haul, when you average the number of times he gets the bid over the number of times he doesn't, he's going to expect that he should profit more than he loses. So when you see expected value, it's outcomes times probability. Remember, these things have to add up to 1. Even if there's more than one thing listed, they have to add up to 1. Think of them as percentage. 7% of the time, 93% of the time, that makes up 100% of the time. I believe we see another one of those a little later on, but let's keep going. This might end up being 2 videos long. We got 8 cans of apple juice, 4 grape. How many of you like grape juice? 12 orange, and 4 pineapple. How many people drink pineapple juice? This is so good. But you got to realize the number of fruit needed to make that 1 can. You wouldn't eat that many fruits. So, first thing I'm going to do, I'm just going to say, what's the total here? Well, 8 and 12 is 20 plus 4. There are 28 total. Okay? Now, we randomly select 3 cans in succession. That means one after another, after another. Pick one, then pick another, then pick another. What's the probability of no grape? Probability of no grape. Well, no grape means we want this one, and this one. So there are 24 that are not grape. So my probability of reaching in and getting something not grape is 24 out of 28. If I am, now I want one and then another and then another, so we're multiplying here. Because I'm doing it in succession. So I pick out a grape, that means there's only 23 cans left. I didn't get a grape that time. I picked out one that's not, so there's 23, but there's only 27 cans left, because we got to assume that you're taking it and giving it to somebody, right? And then the next one is 22, because you've taken 2 cans out, not grape, and 26. And so we're going to multiply all that together. Now you can do some cross-canceling, whatever. You can multiply the top, divided by multiply the bottom. There's a lot of different ways to do it. I'm going to say 24 divided by 28 times 23 divided by 27 times 22 divided by 26 equals, it comes out to 506 over 819. We might need to convert that to a decimal of some sort. I rounded there. Multiple choice, so you should be able to pick it out pretty easily. Okay? But this one here, you're doing it in succession. That means one and then another and then another. We're doing it, you got to multiply.
So those fractions represent a can, right?
Right. There are 24 cans that are not grape and 28 total cans. Stick them in a cooler. And you pull one out. Oh, that's not grape. It's pineapple. Okay. Here you go. There's pineapple. And then you want to get another one, but no grape. So there's now 23 total cans that are not grape because you took one out. And there's only 27 cans because, you took one out. So we're assuming, it makes sense to assume that you're not putting it back. 5. Now there's a table for number 5 on here. Employed and unemployed, male and female. Okay. We may want, table shows number of employed, probability of selecting a person who is employed, given that, this is a very key part, person is female. When we're told a category, given that something, that means we can cross out the other category. What is the other category? The male. So I don't need any of those numbers. Don't even look at them. I want to know probability of someone is employed, and those are the only 2 numbers I have. Now, we're going to have to add those numbers to find the total. So let's do that. Okay, let me go back to my other page because I want to make sure I do it on there. So now we're looking at only employed being 58,655 and unemployed being 22,85 for a total 58,655 plus 22,85 equals, so there's 60,940 females. That many are employed and that many are unemployed. So what's the probability of employed, picking a female that's employed? It's 58,655 out of 60,940. How do you like that fraction? I don't like it. I don't understand it. I would much rather go here and say 0.963 or 96.3%. Okay, I'll take care of that. Thank you. So I'd much better have something like that. From yesterday? All right, next, moving along. It's going to be a double. Number 6. Probability. Okay, this one you can see. You are not dealt a 6. Not dealt a 6. A couple ways to go about doing this. The easiest one is how many are not 6? How many are not 6? Well, there are 4 6s, right, out of 52, so that means there are 48 cards that are not 6. So the probability you get a card that's not a 6 is 48 out of 52. Always reduce. 12 out of 13. No.
Why not?
I don't do TAs. Next question. We got a bag. It has 7 red, 5 yellow. Okay, 7 red balls, 5 yellow balls. Now the red balls are numbered 1 through 7, and the 5 yellow balls are numbered 8 through 12. Now that's a little bit important. Okay, it says the probability of selecting number 3, but it says given that it's red. Okay, that's what it says right there, given that it's red. Well, if it says given that it's red, that means I can cross out the yellow and not consider them at all. It's as if Janessa kind of peeked and saw that I pulled out a red card, didn't know what number it was, but she knows it's a red card. So now it's doing probabilities. The cheater. No, so there are 7 red. There's how many 3s? 1. So 1 out of 7. What happened to the 5 yellow? You don't need them. It said, given that it's red. You know it's red, so don't even consider the yellow. 8. Odds. Remember, odds are wins to losses. That's the generality that we're using. Okay? That you're randomly dealt odds of a black 7. You're given a black 7. How many black 7s are there?
1.
There are 2. How many are not black
50.
7s? 50. Okay? In general, this is, I want a black 7, but if I don't get one, I lose. So what are my odds? 2 black 7s out of 50 that are not, which we can reduce 1 to 25. We can reduce it like a fraction. So you have to consider it as how many ways you can get what you want. That's winning, to how many ways you don't get it. We want a black 7, and the others are don't. All right, you're going to toss a fair coin 8 times. Okay? In other words, it's not one of those 2-headed things that trick people. Okay, it's a fair coin. And toss a coin 8 times in the air. What's the probability of all heads? It's pretty simple. The first head is 1 out of 2. The second head is 1 out of 2. The third is 1 out of 2. 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 Make sure you don't do it to, which is the same as saying 1 out of 2 to the 8th. Why are we multiplying? Because I want to get a heads, and then a heads, and then a and means multiply. Okay. So that's going to be 1 over 256. Pretty sure you'll see a fraction on that kind of problem. But you just, each time it's 1/2. Doesn't change, so. Ten. Roll a die. Roll a die. Find the odds. Oh, there it is again. Remember, odds are wins to losses. Find the odds of a number less than 4. A number, well, how many numbers are less than 4? Yeah, numbers less than 4 are 1, 2, and 3. So there are 3 numbers less than 4. How many are greater than 4? Not less than 4. Not less than 4. Yeah. Not less than 4 are the numbers 4, 5, and 6. So 3 ways to get a number less than 4 and 3 ways to get something not, so it's 1 to 1. 50-50. Okay? Think of odds as how many ways I can get what I want to how many ways I can get something that is not what I want. Let's go to the next one. Cranking through this, just powering. Litter of kittens consists of 1 gray, female, 2 gray, male, 1 black, female, 2 black, males. Probability, so how many, that's like 6 total. Find the probability that you're going to reach in there at night and grab 1 black or female. What does or mean? Add. Or means add. So how many blacks are there? 3 out of 6 total. How many are there females? Whoa, no. Black or a female. Meaning if I get the gray female, I'm good. It's a female, right? There are 2 females out of 6. 1 gray, 1 black. So I either want a black cat or I want a female cat, which seems weird to me because I don't know why you would want a cat anyway. All dogs go to heaven, so why wouldn't you want a dog? Okay? 5 out of 6. If you like cats, that's okay. Not everybody's right. Oh, sure. All right. 12. 12 is a little bit confusing. Physics department. 8 male professors. 4 female professors. 7 male teaching assistants, 10 female teaching assistants. Okay, find the probability that you select, that's not even spelled right. Select a TA, teaching assistant, or a female.
Well, let's be real.
Let's be real.
All the males are picking the female TA.
No, it's either a TA or a female. Why would you say that? My experience, females usually work harder than males.
Oh, okay.
Males goof off more.
Okay.
So how many total people are there? 17 plus 12, 29?
29.
29 total? So how many TAs are there?
17.
So you either 17 out of 29, or means plus. A female, how many females are there? 14 out of 29. Which is not right. There's something wrong.
You have to take what are they, duplicates?
You're Where's the middle?
take out the duplicates, but what are the,
What duplicate?
because this is too big.
There's no.
This is 31 out of 29.
Oh, yeah.
So that's why I told you, this is kind of confusing.
So there's 10
So you take that out.
I think this one is confusing. I think this one, Mr. Ho made a mistake in,
Yeah,
because you cannot tell me where the duplicates are. This should have a duplicate somewhere, but you can't tell me that where the duplicate. So I think he messed up in doing this. I'm gonna blame him. Although he could come and tell me how it works, and I could be totally wrong. He's not stupid, but yeah. But you have to assume that one of the group is a duplicate of the other. Okay, one of the group is a duplicate of the other. So, all right, we'll skip out that problem. I don't think that problem is even on the test, but if it is, it works. We'll have to move on. 13. Roll a die twice. You want a probability of a 6 and then a 4. Now we learned that and meant multiply. If you roll a die, it's 1 out of 6 to get a 6 and 1 out of 6 to get a 4. So that's 1 out of 36. Whenever you're doing one thing and then another thing, doing it twice. Okay? All right. I'm going to stop my video here and start up for this part B.